Okay, so what this question is saying, we need to take the maximum XOR of two numbers in an array. For example, we have given this array, and if we do the XOR of two numbers, for example, 3 or 10, I don't know what it is, but it will be lesser than this 5 or 25. So we need to XOR two numbers such that they needs to contain the maximum of it. And it should be done in order of n times. Like when we go for 3, it is not a contiguous, like we cannot go for it is like any number which is left, for example 3s or 10, 3s or 5, 3s or 25, we can move it like that. Any number which is after taking is or any two numbers, if it is greatest, we need to return. Is anybody has doubt about what is a XOR? If nobody knows, like I can tell what is XOR is. Like it is opposite of or. No. Yeah. So for example, so XOR operation, I'll just write down the XOR operation, what it is. For example, we have 0 0 0 1 0 and 1 1. The answer here would be 0. Only when it is opposite, it is giving 1, otherwise it is giving 0. So how 5 is denoted in a bit wise, which is 1 0 1, and so let's say 0 1 0 1. 5 it by, like this is 4 plus 1 5. Okay, so how 25 is denoted? Let's say 8. First of all, 16.
1101.
1 1 0.
1. 001. I think
Okay.
that 16 plus 9, right? So yeah.
Yeah, 6 plus 9. Yes, it's correct. So what would be the answer over here, which would be like, so if we are taking a XOR of, this would be 1, this would be 1, this would be 1, this would be 0, and this would be 0. So max is this is 4 plus 8 plus 16. 16 plus 12 is 28. So that's a max answer. So we need to give the maximum of XOR. Similarly, we need to go with all these two, any kind of two numbers and making a XOR of it and then answering down. What would be the brute force approach? I want to ask. Anything comes in a mind about brute force?
Just have a two loops, start from first and try all the combinations.
Yeah,
like for 3,
exactly.
try all the combinations.
Yeah. So like with 3, we can go with 10, we can go with 5, 25, 2, 8, and just take a max of it.
Always maintain a current maximum.
Yeah, current maximum and the overall maximum.
Right.
And similarly 10 with 5, 25 to 8. So that would be the brute force approach, and it is definitely n square. And so I did with this, and I got just one case with TLE. So they are expecting some other result, which needs to be done in order of n time, and I think it should be related to some bit manipulation thing. So anyone has any idea about how to solve this question, or anyone has solved this?
So I did this using greedy and a try approach.
Mhm.
So basically, like you have mentioned, so basically we want to get how we'll get a maximum answer. If I have a bit one on, I have a good set of bit ones on leftmost side, and there are a lot of bit, like there are a lot of ones in my, there are a lot of ones in my answer, and starting from left to right. So what I'm telling, if I want to do a greedy approach, I want like every time the maximum time when I'll get one, and from left to right, I'll get the best answer over here. So considering that, if I want to go in that direction where I get better number of ones.
Yeah, which makes sense because if we have at most, and it's an integer number, let's say we have a 4-digit, they want us in a 4-digit. So whatever at the extreme position one, like a left-hand side, that would be the best answer.
So I can share my, I can
But
provide.
again, both numbers should not be higher, right? Because if both numbers have the 1 on the extreme side, it will turn into 0.
Yes. So then we have to go with some, then so let's assume like no number has, all the numbers has 1 on the higher side. Then no one can contribute to the answer. Then we have to go to the other part, the second bit, third bit, fourth bit, in that way.
Okay.
I can share whiteboard and try to explain.
Mm-hmm.
Let me know when you can see my screen. So,
Yeah.
so we know integer is like in Java, C#, it's a 32-bit thing. So that means like there should be 32 bits in a integer. But for simplicity, I'm going to say like I have a new data type where I only have a 3-bit integer. That means the maximum, the minimum number could be 0. The maximum number could be 7. I'm just making it for simplicity. So like the minimum number would be like 0, 0, 0. And the maximum number I can go is 1, 1, 1. Is that clear? Taking a 3-bit. Is that clear to everyone? Why?
Yeah. Yes, it is clear.
Okay, cool. So I just want to make sure like we are on the same page. So in that way, so let's say I have few numbers with me. I have 0, 0, 0. I have 1, 0, 1. And I have 0, 1, 0. And I have one more number, 1, 1, 1. Something like this. So what I'm trying to do here is I'll build a kind of a trie over here where I will have something at my root. So people are, if they are not familiar with trie, still we are not going to use the entire trie concepts here. It will end up like a binary tree. At any point, I will have only 2 states. It will end up become a binary tree, like either 0 or 1. Let's take this number. If I have to construct a kind of a tree structure here, what I have to do? I'll take this 0. I'll put as my, I'll put it in left to my root. Then again I got one more 0. I'll put it here. Then I'll get one more 0. I'll put it here. So I put that in a tree. Then I'll take to another one, which is 1, 0, 1. So root does not have 1 here. So I put 1 here. Then this guy does not have a 0. I'll put 0 here, and then I'll put 1 here. Then we have 0, 1, 0. So I already have 0 at the, now I'm taking this number. I already have 0 here. Then I just need to put 1 here. And then I have to put a 0 here. And then we have 1, 1, 1. Then I'll put 1 here and 1 here. The height of this tree will be always like the number of bits in my system. In this case, it will be 3 because I'm only considering my data type is of 3 bits. When we'll go to integer, then it end up becoming 32. Height would become 32. But right now, let's say I have only 3-bit thing. So with this, I have created a kind of a tree structure where I know where I have put all my numbers in that tree. Is this part clear?
So you have made this tree from the leftmost position, like extreme
Yes.
third bit, using a third bit, and then like on the topmost is the extreme left bit.
Yes, because I want to go from left to right. Because then only I have a better chance of getting an answer. Because the max, if I'm getting 1 on the leftmost side, that will give me a better answer.
Yeah, makes sense.
So now this tree has been formed. Anybody now can suggest me what I should do now?
Go all the way to the right.
So now I will take each number again. So we'll take this number and try to see what best answer I can get out of this number. So I'll again start from my root. So I'm looking for because this is, now I want to be greedy. So this guy is 0. If you see, I want a 1, then only it will give me a better answer. So on my root, I see there's a 1. So I will go in this direction. I will not go in this direction. So that means there is some number which has 1 on the third number, or like on the leftmost side. So I can easily say I can get a 1. I could get a 1 here. Then another 0 comes. Then I'll go to this position. Then over here I will decide whether I want to take left or right. But I have a 1 on my right. I should go in this side, because if I go this side, there's a 1, and when and that is a kind of a opposite of 0. So that means
that is a better answer because it will give us the max result. Yeah, makes sense.
so from this one, now this is something like my current node which I'm visiting. So also we are doing a traversal here. So this is the node which I'm visiting. So here now I'm on this side, I'm here. So here also I see there is a 1 here. So I should go this side and also put another 1 in my answer. And if you clearly see, if I do a XOR of this number and all these ones, I should get this 1, 1, 1. That would be the best answer I can get.
But this would be done after traversing all the numbers.
All the numbers. So
and whatever max is there, so that would be our
so
answer.
I will store it somewhere as my max. And then I will again have something in my current. I will start with 1, 0, 1. And I will start with 1, 0, 1. And again, I will start. So over here, I am looking for something which is 0. So I will go this side. So I will get 1 on this side. Then there is a 0. I want to go on the other side. So I have a 1 on this side. I will put 1 here. And then I'm looking for then the third bit is again a 1. I'm looking for a 0. I have a 0 here. So I can still put 1 here. So if you see, the answer of 1, 0, 1 and 0, 1, 0 is also 1, 1, 1, which is also a better answer. But I already have that in my max, so I should not replace that.
So like just to understand, at first you iterated all the numbers to form this trie. Okay, and then again we are iterating through all the numbers.
Yes.
One by one.
Yes.
And let's say like the first number matched like maybe some max. It gave you like some max. Okay, which is 111 as of now. And at that point, then you stored the both of the things, like the current number, like you stored the max and the two numbers which gave you the max.
No. I only want to return max, so I won't
Okay,
store
yeah.
which two
We
numbers.
don't-
We don't want to like return the numbers. We just want to like return whatever is the max.
Yeah, if I have to return numbers, then I can even store that.
Okay.
Or then I have to think about it different way, or how that two numbers were, or basically what I can do, like while building my trie here at the root, at the leaf, I can store, I can even put what number it was.
Yep. Like, but it's not needed for this question. Okay,
Yeah, it is not needed for this question.
How do you know 111 is a max number?
No, I don't know.
You need to check for, like, there's a 000 in there, right?
So I don't know. I will try all my numbers and then find what is my max. So I will try this number also, this number also. If you see 111 also will give me the same result, because I have 000 on this side.
But we should always try to go with the opposite one. For example, if we have a bit 1, we'll always try to go with the bit 0. And if we have 0, we always try to go with the bit 1.
So let me make it a little more clear. Let's assume in our trie structure, we were not having these things. My trie structure was like this only. And let's say, okay, so my trie was this number and I started with 000, let's say. Let's remove a few things. I started with 000. What I will do, if I have a 0 here, what I want to go towards where I have a 1. So I will try to go this side. I got a 1 here. Correct?
Yeah.
I'll put, then I got another 0. I want to go this side, but there's no 1. So forcefully I have to go this side and I have to put a 0 here. Then here, when I reach here, this guy is 0 and I'm looking for a 1, and fortunately I have 1 here. So I'll go this side and put 1. So answer would be 101 and the current max will become 101, like for now. And if some other number comes, let's say 111, everything will go this side and I will get a better answer, 111, and I'll replace it here. So this is to get, so this is basically, we are doing kind of a greedy approach where every bit I want to get a best answer. If I have a 0, I'm looking for a 1. If I have a 1, I'm looking for a 0. If I couldn't get, then whatever is there, just proceed with that. Does that make sense?
Yes.
So if there is nothing is there, then we just pushing our node. You're not updating the answer, correct?
If nothing is there, like I mentioned in one of the case, there are different ways I can do it. But for example, starting from, let's say we were doing 000, what I did was first I could put 1, then it's as good as I have to put a 0 here, and at the end I have 1. So I can do it in different ways. This 101. So it's up to you how you want to drive that part. There could be help from the language specific help, where there are languages like Java. If I tell what are the bits for 4, it generally tell me it's 100. So easy for me to go bit by bit. But if this is clear, we can go to then we can start talking about 32-bit numbers.
Sure. Sorry, a question from Sonia was, I just want to make sure I also understand the question.
Mm-hmm.
Was it that nothing is there means like whenever we are looking for 1 and we don't have 1, or whenever
Yeah.
is it like that?
Yes. So if we are looking like if we have if there is no node in that path, which is like the right side of this, so we are
Got it.
just updating our
With
node
0.
with 0, or just like whatever the current node is there, we are just moving ahead for that node.
So
Exactly.
basically, if
So
I
in
couldn't
that
get a
case,
flip,
Yeah.
yeah. So
Yeah,
in
that was a similar actually. Asima explained.
so if I don't get a flip, I can't do anything. That is 0 for me. If I have a flip, then it's a 1 for me. Like, because if you see so what is a 0 1 XOR? It is 1. What is 1 XOR 0? So if I'm getting a flip node, I'm taking 1. Otherwise, it is 0 only.
And one thing, if it is, I need to answer it if I am understanding correctly. That, for example, if you put 101, it would be all the bits. For example, if it's not like that your extreme, you will not be having the leaf, because we need to go with the 3-bit, all the 3 bits. Like if we have a number 1 as well, then we need to traverse 001. Like
Yeah.
you need to put all the bits. It is not like that we cannot put all the bits. We need to
So
put
this,
all the bits, or we cannot put any bit.
yeah,
Can
so
we
that is a
can we
good
try an
observation.
example that have only two duplicate number, like an array of 2 number duplicates? So this will be.
So let's say there are 2 duplicates. What is like, there's one more 0, correct?
Yeah.
I will go to try. I'll see 0 is there. I will say again 0 is there. I won't do anything. So duplicates are consumed as 1 number.
So in that case, you look for 1, but there's no 1. So
the answer would be 0, I think.
Then the answer is 0. Let's say this number comes. I'm looking for 0, 0, 0. Then there's no other answer I can get it here. Is that your question?
Yeah, right.
So if I have to do a 32-bit, then I will again do the same thing. But if you see now, there would be extra 32 bits here. So the height of the tree would become 32. Is that clear?
Yeah, makes sense.
So I will always start with root, and then I will have some zeros. Like the height of the tree will be 32. I'm taking all the bits in my tree, and building this tree would be n into 32 complex runtime, and doing the search operation will be also n into 32. So which would be as good as order of n. Because 32 is constant.
Hey, I have a question.
Mm-hmm.
So I was thinking, after we construct a trie, what if we left number and right number? I mean, like the left view number and right view number. Will we guarantee that we get the max value?
Which one? Sorry.
After once we construct a trie with all the numbers, if we take the number which was complete left, I mean, like we try to take the number which we can view from the left view of the tree. Like here in it's 0.
Oh, you're telling like just take the left view of the tree.
Max number?
Yeah, okay. So you're suggesting just take the left view of the, when you say left view, which that would be this one, or so left view would be this one or this one?
Like it can be complete left, or like left and right and left, like that.
I think I'm not getting.
We try to.
Sorry for that. So when you say left view of the tree, what that means?
Here we have 0, 0, 0, and 0.
Okay, so this is a left
We
view
have
of
the number
tree.
0, 0, 0.
Okay.
Yeah. And the right view is 1, 0, and 1.
Correct.
So is it every time guaranteed when we construct the try, and if we take the complete left and complete right number, are we going to get the max value every time? Max
Okay,
or value?
let me put this guy again, which was our original one. I rubbed that. So now the left view of the tree is 0, 0, 0, and the right is 1, 1, 1. So the answer would be 1, 1, 1. So looks like could be doable, but I don't know.
I think it would be like if how you are arranging the tree. Like if your numbers are getting first of all small, then you are making a try with the starting with the small and just ending with the extreme end with the max number. Like if, for example, if your numbers are in sorted, and then you are making a try as well in a sorted manner.
No, but once you build try, you would doesn't matter whether it was sorted or not.
Yeah, but like as he said, like seeing from the left view and the right view, we'll get the opposite direction, and it would be possible when I think
Could be
so.
doable. I don't know.
Even
I
I'm
didn't
not
try
sure.
that. Like whether it will pass all the cases or not. I couldn't think anything on top of my head.
Yeah.
Can you explain how that greedy work? Because, like for example, you see the first bit is you go with 1 first,
No, so,
and you take that path. But if you go opposite way, you may have a better one.
No, it couldn't be right because there would be, okay, let's think in that way. Let's see this. Let's rub this thing. So for this 0, 0, 0, I took the path 1. So if you see, if I took this path, this bit would be like the leftmost side. So you always have a better answer of 1, 0, 0. Because this is on the leftmost side. This will always give me what would be this will be 4. So I would always want to have 4 rather than going in the different direction. Let's say if I went to 0 direction here, I would have like 0. That would not give me a better answer. This would be like a 0 here only.
Yes,
So,
but at that time you don't know what the subtree look like, right? So in the subtree, it could be, if you take the path 0, then it would yield a better answer.
So, okay, let's do this thing. So let's make 0 here and so let's make 0 here. So you're telling instead of this path, I should have took this path, correct?
No, I'm saying like instead of take on one level, the first level, instead of take 1, what if it takes 0?
Yeah, so let's say if I take 0 also. So right now my answer, so if I have took 1, my answer would be if I took what I have earlier explained, if I took 0, 0, 0, my answer would be 1, 1, 0, correct? But if I took an alternate path, immediately if I took an alternate path, it would have become 0 here, which is going on the lower side now.
I believe like the idea here is like we are doing the greedy approach. Okay, we have to look if we can get 1 on the top. Okay, like when we are doing from the leftmost bit to the rightmost bit, whatever ones we can get, we can pick those. If ones are not available, then we don't have any choice. We have to pick 0.
And if I'm taking
or whatever.
If I'm taking 1 here, this answer will be always better than this answer.
Yes. So we have to pick 1. If the current bit is 0, we have to pick the other bit. If it is 0, we have to pick 1. If it is 1, we have to pick 0.
No, but the question is why I didn't went to alter. Why didn't I traverse all my paths?
because like it's not needed. Like we just need to get once in the left mode based.
So,
Okay.
So if we get one in the left mode bit, and then it happened that later we get all zero, versus if we take zero on the left mode bit and then later we get all one. Like that's example. Yeah.
So that's what I put this example here. So if you see 1 0 0 is always better than 0 1 1.
Oh, okay. Because that's the higher bit.
This is like 4, and this is 3.
Okay. That explains it. Yeah. Thanks.
And if you want, so okay, coming back to that left-right view, I don't know. I need to try that. Might be that can work. That's a good idea. Good suggestion. Thank you. But I don't know if it missed some case or not. I can try to run and see if it is passing all the cases or not.
Yeah.
And if you want, I can show you the code. If otherwise, we can proceed further.
So you were saying using there's a way to use without building a trie. Can you explain?
No, I don't know that. I use this greedy approach only. I can show my screen and really quick and show you what exactly I did here. One second. Okay. Okay, let me know when you can see my screen.
Yeah.
Okay. So basically, first I build a trie. If you see a trie, it is have a children left. Basically, again, there will be 2. And that would be again trie nodes. Every trie will have their own children. And then I'm taking a root here, going each number. Now I'm crawling from root, taking that 32 what I mentioned. And now I have to take what is there at my, sorry. Yes. So basically what here I'm doing, I'm pushing this one to 32nd position, or if it is 31, it will push it to the 32nd position, and then everything followed by will be 0. And then I will do a AND with the number. So if I get, so if I do AND with the number and 1 also has that bit, and number also have a 1 bit at that, then my AND would be greater than 0. That means I have to create a child which is like at 1 position. I'm considering if I have a child at 1, that is like a node with 1 value. If I have a child at 0 position, which is as good as a node at 0 value, like with the 0 value. This might be little tricky to grasp, but yeah, this is how I did that. So what I'm doing, like this is only just pushing 1 to 32nd position. When I will become 30, then the one will be at 30th position, 31st position, and so on. If this part is clear, I think then we can do a little bit more on this.
Yeah, clear.
Then again we started traversing all the numbers, and again we start taking all the same logic, like take this push the 1 to 32nd position, do a AND whatever the bit we have. If I have a bit, if I have n greater than 0, that means I'm looking for a 0th bit in my tree. Otherwise, I'm looking for the 1 bit. The same thing I will do here. if I'm looking, so here, if my n was 1 or greater than 0, I'm looking for a 0th here. If it is not null, then I'm updating my result. This is so this is what I'm doing. And it could be done in two different ways. One is this, and other I could have also done like current result equal to current result. I'm doing an OR operation here. So basically, I just want to get put that as part of my answer if it is a 1. So let's assume earlier I was having something like earlier current result was something like 1, 0, 0. And now my I is, let's say, 2. So it will do this OR and 0, 1, 0, 0 OR. Like the answer will become 1, 1, 0, 0. Or other way of doing is this AND operation. I think OR and AND are like kind of similar. Like OR and addition are kind of similar. But these are all bit manipulations. I don't want to spend much time here. I'll send this code in the channel, and if anybody has, like, we can do a chat over there.
Yeah, we have to go for the last question, and it's already running out of time. So
okay.
Thank you so much,
Thank you.
Okay. So if you have any question, then feel free to ask on a channel or as a follow-up. And